In Solidity, sometimes people call non-existent function names in smart contracts, and it can be either a mistake or done on purpose. That's where the two functions, Receive and Fallback, come in handy, and they are very important. Users might make typos in function names when calling them in a low-level way. They might want to just send funds to the smart contract without caring to invoke any functions. And sometimes in proxy contracts, where the function name you want to call only exists in the newest implementation. In this case, you can send the function name to the proxy contract, and it will try to find the exact function in one of the implementations. So now you know the most popular use cases, but we have two functions, so what do they do, and which one should you choose? The easier one, I think, is the receive function, which is used mostly just to send funds to the smart contract. As you can see, it can do some logic, can do some changes to the smart contract, but it's not the most important functionality. I deployed two contracts to show you how it looks in practice. And as you can see, my contract has no functions in its interface, so I can use only low-level interactions. I know that the contract has a receiver, so I can send empty call data with some way. So I'll just send 100 way and click on transact. As you can see, the balance has increased, so I sent the funds, and also it's changed X to 2 and Y to message value. Message value was 100 way, so Y should be 100 way too. But what happens if we don't have the receive function? In this case, we have the fallback function, which is payable, so it will accept the funds too. But fallback function doesn't necessarily have to be payable. It can be non-payable too. In this case, there is no function to receive the funds, and the IDE will show an error. But what you need to know is that in call data, you can provide function name which you want to call, even with arguments. And to do this, you can use, for example, online ABI encoder and provide the function name and arguments. So in my case, it's a simple mint function. And I copy the encoded data, which I can paste here. And now when I use 100 way again, the call data is not empty, so it won't trigger payable receive, but it will trigger payable fallback function, and it will accept the funds too. But that's only if the fallback function is payable, and that's not always the case. So it's usually great to have a separate receiver function, which will always accept the funds without any function trigger. Now let's try non-payable fallback, like in this contract. So I'll copy the same call data. So I want to mint something. I'm looking for the mint function. And as you can see, without providing the value, so without sending any money, it invoked the fallback function successfully and changed X to 1. But knowing that it's non-payable, if we send some funds, so if you don't have a fancy proxy smart contract and you don't want to collect funds of the users who make typos in their transactions, you might want to use fallback without the payable function and a separate receiver which is payable, so that users can send the money to the smart contract in an explicit way. So that's how fallback and receive work. When the caller is a user, he uses an IDE, like in our case. But sometimes the caller can be a smart contract, like in this case. And here you can see that we have two functions, which we'll call and see what happens. So I'll deploy the caller contract. And here's the smart contract. As you can see, one function is non-payable and the other one is payable. So let's see what they do. The first one does the thing we did in the ABI encoding service, but it does it natively in Solidity. It uses ABI encode with signature and pastes the non-existing function. So in our case, it was just like mint or whatever you're looking for. Then it requires success, which is only true if the function really existed or if it was handled by the fallback function. And this is all the standard logic, and we could end the function here. But down below, we can see that we have two other things, which is trying to send some funds to the address we are interacting with. And here you can see that we return the status of the transaction, and it will always return false because we are not able to send the funds because this is not a payable function. So let's try to call this call test function. And to do this, I'll just copy the address of the test contract and paste it here. As you can see, it passes, but in case I send any funds to the smart contract, like for example 10 way, it fails because the function is not payable. So now let's look at the second function, which tries to invoke a non-existent function too, And it requires that it's handled in some way. So it's handled by either a fallback or that the function indeed exists, but it's not the case here. Then it calls the non-existent function again, but with value, so it needs to be payable and we need to send some funds to this function. And the last thing is sending some funds, but with no call data, with no message value, so like with the empty field here. And if you remember what it does, it tries to trigger the receiver function and uses the fallback function only if the receiver doesn't exist. So let's invoke this call test payable function. And to do this, I'll copy the address of test payable contract and paste it here. And as you can see, it fails. And it fails because I haven't sent the funds. So as you can see, we need 9 + 1 way total. So I'll type in 10 way. And as you can see, it has passed. And now let's make a simple walkthrough after triggering the function. So let's click on the debug option to start the debugger. And let's set some breakpoints. I'll need breakpoints for triggering the call and for receiver and fallback function. And now let's move to the start and click on jump to the next breakpoint. As you can see, we jump to the first call, which sends the function signature, non-existing function. So it should trigger the fallback. And indeed, it triggers the fallback. Please ignore the Solidity state because it's bugged and doesn't show the actual values. Sometimes it works, but you need to refresh it a few times. So now let's jump to the next breakpoint. And you have the second call, which has a value and also the function signature. So again, it has a value, so it has message data, so it should trigger the fallback function. Clicking on the jump to the next breakpoint, you can see that it's called our fallback. If it wasn't payable, it would show an error and the whole function would fail. Now the last call, which is a call with value but without message data, it would trigger the payable fallback, but we have our receiver, which will handle this function. So let's click on jump to the next breakpoint, and you can see that receiver is being called here. So that's how those two functions work in practice. If you like our videos, make sure to leave a subscribe and like. We plan to create more Solidity essentials if you like those. Thanks and see you next time.